When we are writing our programs using OpenSQL, we need to bear in mind the concepts of authorization in an SAP system. Now, an SAP system has its own security tools to ensure users can only access the data they are authorized to see. This includes individual fields as well as individual records. The way authorizations are set up can also limit how the data is used, whether a user can only display information or whether they can modify the data, such as adding, changing, and even deleting records. And all these rules that make up a user's authorizations are stored as authorization objects. Now, we're not going to dig deep into authorizations here, but as a general rule, a user is assigned a relevant authorization profile or composite profile against their user record, which for informational purposes is managed through transaction SU01. This authorization profile then gives the user the correct rights to carry out their job. And SAP delivers lots of predefined authorization profiles with their base system that system administrators can use and enhance to apply to their users. For example, there are standard developer roles or HR administrator roles. The system administrators more than likely take these delivered authorization profiles, tweak them a little bit to ensure they work just how their company wants them to work, and then apply them to individual users. Once a user is assigned a role and tries to execute a program, depending on the authorization role of the user, they will be allowed to execute the transaction or not. And a typical example is being able to run transaction SE38, the ABAP editor. A user can be given a role to allow them to access that transaction, but also it can be tweaked so that, they can access it, but only in display mode. Or in a live system, maybe they can access the transaction in display mode and be allowed to debug the program in the live environment, but not be able to make changes to the code itself. So coming back to our ABAP programs, where specific authorizations have not been implemented, we can get our programs to carry out an authority check using the ABAP statement authority check. This has to be used if the transaction or the ABAP program itself is not sufficiently protected by the standard authorization profiles already set up in the system. Now, we won't go any further into authorization checking in this course because it is a massive topic in itself. But you do need to be aware of authorizations and make sure any programs that you create take into account authorizations already set up by the system, or, if required, implement your own authorization checking as just mentioned. So far, we have learned how to read data from database tables. It's now time to take a look at how we can modify and delete data using ABAP. There are some important concepts to keep in mind when going through this module, including the architecture of our system. Now, as a reminder, we have a three-tier architecture. We have the client, who uses a tool such as the SAP GUI to request data from the application server, our second tier, which in turn communicates with the database server, our third tier. Now, when we create our programs, you have to keep in mind that there could be tens, hundreds, maybe thousands of users all accessing the same data at the same time. And we need to ensure the programs that we create do not cause any problems with the rest of the system, and ensure we access the most recent version of the data held on the database when our program runs. Because think about it, if you've got thousands of users, you've got records probably being updated every single minute of every single working day. And you need to make sure your programs can read, add, and update data that is current in the system. Now, fortunately for us, an SAP system takes care of a lot of this work for us. and the ABAP programmer doesn't have to worry about the underlying technology of how records are locked and being used by other programs at the same time. And one of the key tools that we use in our programs is what we call OpenSQL. Now, no doubt many of you have heard of SQL, standard query language. SAP have introduced what's called OpenSQL, which acts like an interface between our program and the database. By using OpenSQL, we can read and modify data and also buffer data on the application server, which in turn reduces the number of database accesses our system has to perform. And it's the database interface that is also responsible for synchronizing the buffers with the database tables at predetermined intervals. Now, when we are creating programs, we've got to keep in mind that if data is buffered and we are reading this buffered data, it may not always be up to date. So when we create tables, we need to create them in such a way that we tell the system that buffering can be used or it can't be used, or maybe it can only be used in certain situations. And when we created our example table in the system in the earlier module, we touched on this, and we told the system that for our table, do not use buffering. And by using this setting, that meant every time we read data from our table, we will always read the most up-to-date records. We will not be accessing data that was read from the table, say 5 seconds, 10 seconds, or even a minute, 5 minutes ago. Now, buffering can be great for tables that hold master data and configuration settings, because data in those type of tables don't get updated on a regular basis. But when we're working with transactional data, it's a whole nother ballgame, because if you've got thousands of users telling the application server to process transactions on transactional data, well, when we read that data, we want it to be as up to date as we can. So we don't want buffering set on transactional data. And if you are dealing with transactional data where the tables are configured to use buffering, you have to ensure your program can take this into account and make sure the buffer gets updated with brand new data at the time you need it. Now back to OpenSQL. Remember, I said that OpenSQL acts as an interface between our programs and the database. And when we use OpenSQL statements in our program, we are only allowed to access tables through the ABAP dictionary. This is our interface. We don't actually access the database tables directly through our programs. Now, there's no need to worry about how we go about doing this, because in our programs we use OpenSQL statements just as though we were accessing the database tables directly. We don't have to think about it. OpenSQL as an interface manages the database access all by itself. All we need to do is code our statements just as though we were accessing the tables. But we will have the underlying knowledge that by using OpenSQL, we are accessing the data through the ABAP dictionary, which has a built-in level of safety to ensure our ABAP code does not have a direct effect on the SAP database system itself. Let us now consider locking concepts. And when we talk about locking, I'm referring to locking data in database tables. And there are two basic types of locking data that we need to bear in mind. First of all is database locks, which lock data in a physical database. So what I mean is, when we update a record, a lock gets set on a record, we can update it, and then the lock is released. The lock is there to ensure that once we set it, only we can update the data. Then once we release the lock, that data can then be accessed by other people. Now, these locks are not sufficient in an SAP system, and they are generally only used when a record is being modified in a single-step dialog process. Now, what I mean by a single-step dialog is that if we have a screen that contains all the data that we need to work with, and we click a button to update the data, and because everything is held on one screen, it can be updated in the database in a single step. Therefore, the database can set a lock, update the data in the table, and release the lock all very, very quickly. As you work with SAP systems, you will realize that database locks are not sufficient. And this is because transactions in an SAP system often occur over multiple steps. So let's say if we add an employee record to the system, we may have to fill in 10 screens of data. The first step may be the name and address. The second step would be the position that they would fill in the system, and so on. And the user, when they enter this data, only want the record to be added to the database at the very end of the transaction when all the data in all the screens has been input. So think about this. If we try to save the data that was entered in the first screen into the database, then moved on to the second screen and saved that, what happens if the user quit halfway through entering all these 10 screens of data? We would have an invalid record in the database. We may have updated a few tables, but we really require maybe 5 other tables filling with data for us to have a valid record. So this is what I mean by using database locks with multi-step dialog processes is not sufficient. So SAP have introduced its own locking concept that is completely independent of the database system. SAP have created lock objects that enable the system to lock data records in multiple database tables for the entire duration of the SAP transaction, provided that they are linked in the ABAP dictionary via foreign key relationships that we have already looked at. As we are not covering dialog programming in this course, we won't go into detail explaining the step-by-step procedures to follow for creating database locks, but we will continue with a brief overview of the topic before moving on. So as I previously mentioned, SAP lock objects form the basis of the lock concept, and they are completely independent of database locks. Now, a lock object allows you to lock a record for multiple tables at the same time for the entire duration of an SAP transaction. And for this to work, the tables involved in the transaction must be linked together using foreign keys. If you remember, we introduced foreign keys in an earlier module. Now, we used the ABAP dictionary to create lock objects, and they contain the tables and key fields that make up a shared lock. When we create the lock object, the system automatically creates 2 function modules, which we will come to in a later module. These function modules are simply just modularized ABAP programs that can be called from other programs. Now, the first function module has the action of setting a lock, and the second one releases the lock. And it is the programmer's responsibility to ensure that these function modules are called at the correct place within their programs. When a lock is set, a lock record is created in the central lock table for the entire SAP system. Now, all programs must adhere to using the SAP lock concept to ensure their programs set, delete, and query the lock table that stores the lock records for the relevant entries. We're not going to go into lock objects any more than this, and for the rest of the course we will just assume that the programs you create and the tables you access are going to be exclusively used just by yourself. Let's now start looking at some of the OpenSQL statements we can use in our ABAP programs. Now, in a previous video, I mentioned OpenSQL statements we use in our programs allow us to indirectly access and modify records held in the database tables. Many of the examples we have used in this course so far have used the select statement, so you should be familiar with that. The select statement is very similar to the standard SQL select statement that is used by many other programming languages. The beauty about OpenSQL is that we can use these type of statements in our ABAP programs no matter what the underlying database is. Our system could be running an Oracle database, Microsoft SQL database, or any other. By using OpenSQL in our ABAP programs, in conjunction with using the ABAP dictionary to create and modify our database tables, we can be 100% certain that our ABAP code will not have any issues in accessing the data held by the specific type of database our SAP system uses. Now cast your mind back to when we created our first database table. We included the field mandant, M-A-N-D-T, which represents the client number and forms part of our database table key. If you recall, when we created our database table, we included a field called client. Let's take a quick peek as a reminder. Here it is. Now this field represents the client number and forms part of our database table key. So in our ABAP programs, you would think we would have to use this field when we're using our OpenSQL statements. But actually we don't. This is like a hidden field. All our transactional tables and the majority of our master data and configuration tables include this field in them. And the SAP system is being built in such a way that it will automatically apply a filter on this field based on the client ID the user is using. So if I am logged in to client 100, the SAP system will automatically filter all the records held in the database on this client key and only return to me the records for client 100. This is done all automatically. So when we use OpenSQL in the programs that we create, the system will manage this for us, meaning we never have to include this field in any selection or any update statement we use in our programs. This also has the added benefit of giving us security in the knowledge that any OpenSQL statement we execute in our program will only affect the records held in our current client. So there are 5 basic OpenSQL statements that we will use all the time in our programs. And these are select, insert, update, modify, and delete. So first of all, the select statement. Now you should be familiar with this already because we have used it in quite a few programs. And the select statement allows us to select records to use in our program from database tables. Next up, we have the insert statement. This allows us to insert new records into a database table. Then we have update, and the update allows us to modify records that already exist in the table. And then we have a modify statement, which does the same, but there is a slight difference that we will come to. And lastly, delete. And yep, we can delete records from a table. Now, whenever we use any of these statements in an ABAP program, I want you to get into the habit of checking to see if the action that you have executed has been executed successfully. Because if we try to insert a record into a database table and it actually didn't get inserted correctly, or maybe it didn't get inserted at all, then we need to know this so that we can take the appropriate action in our program. And you do this by using a system field that you have already seen when we took a look at debugging our program. And this is sy sub rc. Now when one of our statements is executed successfully, this field will contain a value of 0. So all we need to do is check for a value of 0 and then continue with our program. But we need to check if it doesn't contain a 0. If our statement was not carried out successfully, this variable will contain some other value, and depending on the individual statement, the value can have a different meaning. Therefore, you must make sure you understand what the different return codes are for the different ABAP statement you are using. You will find that in practice, it becomes second nature, and many of the standard statements use the same return code to represent similar results. But don't count on this. Make sure you know how to check the individual return code for each statement, and you know what each of the individual return codes means. That way, you can code your program accordingly to take the right action depending on the result. Now let's move on and start using some of these statements in a program. We've already seen the select statement in action, so let's skip that one for now and we'll focus on the next statement down, the insert statement. First of all, I'm just going to comment out what we have here. Oops. There we go. And we'll take the scenario that we want to insert a brand new record into our Z employees table. So in its simplest form, what we would do is write insert followed by our table name with a full stop at the end. As you can see, this is super simple. But one little thing to note is if you use this form of the statement, you always must specify the table name. You cannot use a variable instead. Now next, as I mentioned, get into the habit of checking sy sub rc. And I've just noticed I made a mistake. It's sy dash sub rc. So once we have our insert statement, then you would write some sort of check statement if sy sub rc not equals 0, or it can just be 0. Then we would do some statement. So that will ensure we capture any errors that happen with the insert statement, and we can take the appropriate action by including some code right here. Now let's step back just a little bit and go through this statement again in a little more detail. And the reason we're doing this is because we don't want to use this form of the statement. It includes some bad practices by today's standards, and is a throwback to some of the older ABAP programs that you will no doubt come across when working with an SAP system. So what do I mean? Well, take a look at the statement again. All it says is insert table name, insert Z employees. You might wonder, what are we actually inserting? Well, this is where we need to introduce a concept called a work area. And the ABAP statement we have just written expects a work area to exist that was created when we declared an internal table. And this type of work area is often referred to as a header record. So let me bring in Microsoft Excel to try and explain a header record and how it's attached to an internal table, and compare it against a standalone work area. Okay, so I'm going to try and represent a normal table here. What we would normally have is record 1, and we would have field 1, field 2, field 3, etc. Then we would have record 2, record 3, record 4, record 5. And they would all contain their individual fields. So we would have an entry for field 1, for field 2, for field 3 in every record. Now, if this is our table, let's give it a nice border, Then when we work with an internal table with a header record, we have this additional record up here. And this little guy is what gets populated when we reference the table just by its table name. Or in our case, where we chose the insert. So what would happen is whatever was existing on this header record, when the insert is executed, this record would be inserted into the table body. This header record only exists in memory whilst our program is being executed. It doesn't contain a record held in the table itself. It's just a place for us to work with a current record. And that's where the term work area comes from. We just use it to hold the current record we are working with. So, when we are working with the data in our program, we're always referencing this header record just by using the table name. And it can become a little bit confusing because you think you're referencing the table, but actually no, you're working with a record held in memory that has the same structure as the table. The fact that the table and its header line have the same name leads to confusion. Now, with the introduction of ABAP objects, which we don't cover in this course, but I highly recommend you take a course covering ABAP objects, this method of using this type of work area is no longer valid. ABAP objects will not allow you to reference a table by using its header record. So like I say, this is a bit of a throwback to how ABAP was coded many years ago. And with the changes in the language that have come about over the last, I was going to say few years, but boy, it must be 6 years, 7 years. This way of referencing a work area for a table is no longer used. And you shouldn't create programs yourself using this type of work area. So to avoid any confusion when working with internal tables, you should make sure your programs work with separate work areas. And what do I mean by this? Well, it is similar in a way to what we have here. Let me pop it down here. If I do an insert, so this example is a table with a header record. This one is an internal table without header record, but we have a separately defined work area. We'll call this WA. And this is our table. So when we write code, we can reference the table by itself, and when we reference the work area where we want to work with a record in memory, we reference a completely separate work area. It will have its own name, so it will be clear that it does not belong to the table exclusively. It's a separate structure that we will create in our program that sits by itself. So let's go back to our program code and have a look at how we can declare a work area. So you should be familiar with the data statement. And that's exactly what we do to declare a work area, because, you know, in reality, it's just like a normal structure. All we do is data, and we'll give it a name. Let's say WA employees. Then we need to give it a type. Well, remember we're working with a table, so I'm not going to use the type statement and declare, you know, a character field. I'm going to declare a bunch of fields that make up the table. And the easiest way of doing this is use the like statement. And we're going to say our WA employees work area is like Z employees, which is our table. So our WA employees work area will take the same structure as our Z employees table. But it won't be a table as such. It will be a record structure, not a table structure. So our work area will only store one record. So once we declare our WA employees work area, we can then change our insert statement to use the work area to insert a record into the table. And we do this by editing the insert statement. Instead of saying insert Z employees, we will say insert Z employees from WA employees, which is our work area. It would help if I could type. Here we go. Now also, with this form of the statement, we could actually use a variable here to identify the table. So instead of doing insert table name, we can do insert and put a variable there that we may have populated earlier with our Z employees table. And the only thing to remember is if you do use a variable, you have to enclose it in brackets. So our insert statement would look like this. Insert our table name in brackets. I'll remove that for now and we'll concentrate on the basic form. So now we've declared our work area, we've got an insert statement. One thing I need to do fill our work area with some data. So to do that in this example, I'm going to remind myself of the structure of Z employees. I could use forward navigation, just double click, but I'm just going to open up a brand new session. And I'm going to copy these fields. Paste them in. Remember, copy and paste is a coder's best friend. Oops. So what we would do is fill out a work area with a new record, and I'm just going to check what data we have in the table first. Forward navigation this time. Okay, we have used up to 1, 0, then 5. So let's fill in a record. Six. Tell you what, let's give it a proper surname. Whoever Westmore is. Bruce. wasn't born in 2000, let's say 1992, 12, 13. So now we have our data statement declaring our work area. We are filling our work area fields with some values. We're then going to insert our work area field into our table and check that everything works successfully. And for this check, let's have a write statement. We'll change this to an equals. So if it does equal 0, write this statement out. Else, we have a return code of sy sub rc. And don't forget to use the change statement. Let's make sure everything looks good. Give it a check. And then we should be able to execute our program. Before we do execute it, I've noticed a mistake or two. Got way too many zeros. Oops. I think it's 6 because I think it's an 8-character field. Let's go and check. Yes, it's 8 characters. And also, now I think it's definitely my keyboard playing up. It's not me not being able to spell, honest. Okay, so now we'll check the program. Everything's good. Make sure it's saved, then we'll activate it. And then we'll test it. So if I bring up the database table as it currently is, and view the data, they're the current records we have. So I'll move it over to the side. We will execute our program. Record inserted successfully. So come back over here. We'll do a refresh. And there's our new record at the bottom. So let's now, just for practice, let's go through this in debug mode. Now we'll change the contents. No, we won't. We'll leave it like that. What we'll do is delete the record from the table. So whilst we're here, highlight that one, table entries, and choose delete. And it's gone. And then I'll put a breakpoint. Oops, cursor was placed on the wrong place. Do apologize. Stick the breakpoint there. Okay, now we'll execute the program and we'll step through it one line at a time and check the value of the sy sub rc field. Okay, so we're in debug mode. So I'll press F5, which is the single step. And you can see here that we're going to fill our work area. So what I'll do, I'll double click on the work area structure up here first. And there you can see the work area, and it actually, if we hover over, you can see it's completely empty. But what we'd like to do is display the whole structure, so see the individual fields. So I'm going to double click it, and now it's jumped to the structure view where we can see each field within our structure. Now, due to the limitation in size here, we can only see a very small preview of the code. But let's go to the actual line of code we're working with. So we have executed this one, and you can see we have filled the employee field. The next field, surname, gets filled, and so on, forename, title, date of birth. And now we have the insert statement. And what I'm going to do is go back to this fields view, and I'm going to bring up the SY sub RC field. Well, I say bring up, here it is down here. It's always on the screen. So at the moment, it has a value of 0. And as we execute the insert statement, if there were any problems at all, this would change to a 4 for a warning, and then an 8 for an error, or to say it was unsuccessful. So let's execute the insert statement. We can see the value is still 0, so everything has worked correctly. We're now going to query SY sub RC, then write out the message, and then the program will finish. Step back to come out, and then we'll do a refresh on the table, and there we have it. The new record has been added. So that's the insert statement, using a separate work area. Now, as we move on, there is a separate module looking at internal tables, where we will discuss internal tables with header records and internal tables with separate work areas. So we will come back to the work area, header record topic a bit later on. Now at this point, I want to introduce a new statement called the clear statement. And the reason why I want to do this is because in our ABAP programs, you won't just see programs that start at the top, fill data like we have just done, do the insert, check that it was successful, and then process another record. You would have loops set up and things like that, so that you can write just a small section of code that maybe could insert 100 records. And to do that, we're going to reuse variables and structures in our program over and over again. So the clear statement enables us to clear out a field, a variable, or structure so that we can reuse it and make sure that none of the data that currently exists in the structure gets applied to a new record. Now you will see the clear statement being used an awful lot in programs, because every programmer makes use of existing fields within their program time and time again. So in the scenario we have here, we fill our work area with data. Let's take off this breakpoint and this one up here that I set accidentally. So our program fills our work area structure, then inserts the data into the table, and then we do some validation checking. Well, now if we want to insert a new record, in this case, all I'm going to do is just copy the code. Yeah, just a little break there just to show that we got something new. Change the employee number. So now to do this, well, let's say this didn't exist. If we did an insert statement again at this point, our work area contains all the values from our previous insert, and we wouldn't want that. We want to clear it out. So once you finish working with a variable or structure, use the clear statement and specify what you are going to clear out. You have a couple of options. If we use clear WA employees, it's going to clear the complete structure, so every field within the structure would be wiped clean. Alternatively, you can specify individual fields. So let's bring back in the fields we commented out. just so we'll just leave them like that, and then we'll run our program in debug mode so you can see the clear statement in action. So first of all, we'll check the program. Everything is good, and we'll activate it. Set a breakpoint, and let's go. So instead of, well, I'll do it again. I'll double click Z employees, which is the whole structure, but this time let's do the individual fields. I'm just going to double click each field, and as you can see, it's added to the list at the bottom. I will wipe this one out. Oops, sorry, wipe them all out, start again. Let's do these 4. I can do a 5th, but we'd have to page down to see the date of birth. So I'll just keep it at 4. I'll do F5 to go step by step, and we can see everything being inserted. Then the insert statement, the record gets written to the database. Now, we still had the original record in the database, and check this out. Our SY sub RC has given us a return value of 4, indicating we've got some sort of error. So now our write statement will write out the return code to the report, telling us about the error. And this is because the record already exists. So we're trying to create a brand new record with the same key. And this just won't work. Our table requires unique records. So the system here is saying, the insert statement didn't execute properly. We have a problem. It's giving us the return code. We are checking for it. And then it's going to write out this comment to the report. And now we come to our clear statement. This is what I wanted to demonstrate, not so much the error. But we're going to execute the clear statement on this individual field, and it's going to clear out employee only. There we go. See, it's been initialized to 0s. We don't have the clear statement for surname and forename, but because we are filling all the fields again, there's the employee number, everything will work. But in practice, I should have cleared out the whole structure, not the employee. So we go along, insert. This time we do have a unique record because we changed the employee number, and we can see SY sub RC is 0. And this time it will write out a row saying record inserted correctly. And that's the end of our program. And there we can see the first one, we have a return code of 4, and then record inserted correctly. So before I forget, I'm going to wipe out these records right now. So if I do a refresh, here we see the 7th one. There we go. We're back to where we were. Let's move on to the update statements. Okay, first of all, I'm going to tidy this program up a little bit. And what we will do is now take a look at the update statement. Now, the update statement allows us to modify one or more existing records in our table at the same time. Now, in this example, we're just going to focus on updating one record. But to update multiple records, the same sort of thing applies. So just as with the insert statement, we first of all would declare a work area. We would then fill our work area with the data that we want to update the record with, and then proceed to execute the update statement, which would take our data, update the record in the database, and then give us back a return code to tell us if the update was successful or not. So as we have already got a table structure, or work area structure should I say, WA employees, let's use that so we don't have to declare it again. But what we will do is change these contents. So we will let this insert statement run through, insert the record, and then we will update it with some new values. And instead of Westmore, let's use Eastmore. And we will change the guy's name to Andy. Now, very similar to the insert statement. Might as well copy this checking as well. What we will do is instead of insert, we will use update. And just like the insert statement, the simple form would be just update Z employees. And that would update using the header record. But as we don't want to do that, because it's the old way of doing things, we want to use our separate work area. So, back in our program, we would say update Z employees from our work area. So that's it. We don't need to do any more coding. Let's just test it out. So I'll save the program. Let's make sure it compiles okay. Oh, we do have a problem. Let's have a look. Missing period. Oh, just off the end if. There we go. Everything looks good. We'll put a breakpoint in and run through. So we're going to insert our record. Check for the SY sub RC on the insert. Yes, it's 0, so everything is good. And now we're going to get to the update. So the first thing, which I forgot to do, but it doesn't really matter in this case, is I should have used the clear statement and cleared out employee surname and forename. But because we are updating every single field again, it won't really matter. So I'll step through. The employee is exactly the same. Our surname will change to Eastmore. Forename to Andy. Mr. Date of birth. Now the next one is the update statement. So first of all, while we're here, let's bring through the other session. We'll do a refresh. There's our new record. Let's go back and execute this update. SY sub RC is 0, so that indicates everything is good. Oh, and look, I didn't update the actual comment to say record updated correctly. Never mind. But because the update has been executed, if I do a refresh, we should see Westmore changed to Eastmore and Bruce changed to Andy. There we go. And I'll just press F8 to zoom to the end of the program. And there's our output. Get rid of that breakpoint. And just for completeness, I am going to change this. And it would be nice to put these on the new line, wouldn't it? There we go. And you know what? That is it for the update statement. For our next topic, we're going to look at the modify statement. Now, the modify statement is like a combination of the insert statement and the update statement. You can use it to either insert a brand new record or modify an existing one. But in general, you want to use the insert and update statements where you can. Don't be lazy and always try and use the modify statement. The insert and update commands offer greater clarity to those people reading your code. and it's clear to you when you're writing your code. You know exactly what the code is doing. Now there are times when you have to use the modify statements, because sometimes you will be writing code that either has to insert or update a record, depending on certain situations, and the modify statement is fine to use in that regard. So let's have a look now what the modify statement looks like, and I'm sure it'll be of no surprise to you. It follows the similar syntax of the other statements. So again, I'm going to copy some code. And we'll first of all take a look at the basic syntax. Oops, shouldn't have double clicked. And this is it. A simple modify Z employees. And as with the other statements, this will use the header record of the internal table. But we do not want that. We want to use the work area. So our modify statement looks very similar to the others, where we will modify our table, Z employees, from our work area. Now when the modify statement is executed, the primary key fields from your work area will be checked against those records held in the table. If a record exists, that record will be updated with the contents held in your work area. If the record doesn't exist, then a new record will be inserted at the end of the table. And as with the other statements, if the modify statement is unable to execute either of these two tasks, the sy sub rc field will return with a value of 4. But if it's successful, it will contain a value of 0. So let's go ahead and let's stick with this theme and actually call this guy Northmore. First name of Peter. So this should update the existing record. Change this to modified. Now put on a new line. And then what we will do we will look at the second scenario where the record doesn't currently exist, so it should insert a record. These are really bad names I'm choosing, but never mind. There we go. So let's recap the code. Tell you what, let's do what I should have been doing anyway. Insert the clear statement. There we go. So now we'll recap. So the program will insert a record first, 06. It will then update 06 with the surname and forename. Then we will get to our modify statement, where because we are using the correct key, the action performed will be the same as the update. We will update the surname and forename. Then we'll come down, do the modify again, but this time, because it's a unique key, a brand new key, we're going to add a new record. So let's do a syntax check. Well, pretty it up first, yeah, syntax. Then we'll activate. Let's check our data in the other session. We'll get rid of 06 first. refresh. Oh, it's already refreshed. So we've got to 05. So let's debug our code. F8. And now we will step through. There's our insert statement. Everything is good. Do a quick refresh. There's our record. There's the Westmore. Now we will do the update. Change his name to Eastmore and Andy. Everything is good with the SY sub RC. Let's do a refresh. There's Eastmore. And now we get on to our modify statement. We'll do the modify. SY sub RC is 0, so everything is good. Do a refresh. We've changed to Northmore and Peter. And the last one, this is where we'll do the modify statement again, but it should insert a brand new record. So we've executed the clear statement, it's wiped everything out, generating our brand new record, modify, SY sub RC is 0, write out the success statement to the report, do a refresh, and there's our brand new record. Let's move on. The last statement we are going to look at is the delete statement. There are no prizes for guessing what this statement does. As I mentioned previously, you must be careful with this statement because if used incorrectly, you can end up wiping out the contents of your entire table. Don't let this put you off using the statement though. You just have to be aware of how it should be used within your programs. So let's go and have a look. So if we focus on the program again, we will create a new section for our delete statement. As usual, I'll do the copy and paste. So I'll leave in some of the right statements and delete what we don't want. Okay, before I change anything else, let's just discuss this delete statement. And in contrast to the other SQL statements that we have looked at already, the delete statement only needs to take into account your primary key. So what I mean is, when we want to delete a record from our table, we only have to tell the system what the primary key of the record is for that record to be deleted. So in our case, all we need to do is, first of all, let's clear out our work area. So it's completely empty. Then we will fill our employee field, which forms part of our primary key, with the last record we have created. So in this example, we will just delete the one record that has the employee number of 1, 0s and a 7. Let's take a look at our table again as a reminder of our primary key. Now you can see the key is made up of two fields, the client field and our employee number. Now remember, the client field is handled automatically by the system. So our programs never need to feed our SQL statements the client field. It's all automatic. All we need to do in this case is specify the employee number that we want to delete. So let's go back to the table view and pop it to one side and back to our code. So once we specify the employee number, we then just need to create our delete statement. The syntax for the delete statement is this. We have the delete, followed by the table name, followed by the from addition, followed by our work area. So this delete statement will say delete Z employees from WA employees, and WA employees contains the table key 1 with 0s and 7 to ensure only that record identified specifically in the work area will be deleted from our table. And as per the other SQL statement, we need to check the SY sub RC field to make sure the record was deleted successfully. And we might as well leave this clear statement at the bottom. So I'll do a pretty printer, make sure it all looks good, then a check, and then we'll activate and debug. So as it stands at the moment, we have all these records in the system. This is where 07 is created. This is where 06 is modified. And we update it there and we insert it there. So what we will do is clear out 6 and 7 from the table so they get deleted. Sorry, they get created once again. Oops, I didn't do 7. Oh, maybe it's a refresh. Yep. Okay, so now we can debug. Let's stick a breakpoint on and test. Oh, 1 second, I need to reactivate. There we go. Now I can put the breakpoint on. And the code has run through to our breakpoint, so it should have created record 6 and 7 automatically for us, which it has done. And then we'll keep an eye on SY sub RC. And we'll just bring up these fields to monitor. So the clear should clear out these fields. And we'll populate the number. Now remember, this table has the 06 and the 07 records still there. We will execute this next statement. SY sub RC is still 0, so that means everything worked correctly. If we go back to our table and do a refresh, we can see 7 was deleted successfully. So then the code should carry on and just output record was deleted successfully. And there we go. How simple can it get? Now, before moving on, let's have another look at the delete statement, but use a slightly different form. We are not just restricted to filling in the table key and deleting records that way. We can also use logic to determine which records we want to delete. So for example, let's create some more code. And what we're going to do is just copy this section once again. We don't need that separate one. And we're going to write the delete statement as follows. We're going to get rid of this filling in the key, but we're going to say delete from employees. But this time, instead of from, we're going to do where. Then we specify a field. So let's have a look at our table. And we can choose to delete records on surname. So if we say delete where surname equals Brown, then it should delete any records that have a surname of Brown. Now, just to show that our example will delete more than one record, let's create a new record that has a surname of Brown. So let's step back out and then we'll do the utilities, table contents, create. Use a number of, let's make it 10, just to jump a few. We'll create Brown. Give it an excellent first name of QWERTY, and it's a Mr. And let's choose 1st of January 77. Save that record. One step too far, then we'll view our data. And there's our brand new record with the surname of Brown. So now let's get onto our code and delete all the Brown records. So here we have delete Z employees where specify the field, which is surname, and we'll say equals Brown. Then we'll check to see if the records were deleted successfully. And we know in this case we're going to have 2 records. And we'll leave the clear in there just in case we need it later on. Pretty up the code, check the syntax. Oops. I do apologize, I got the syntax wrong. The delete statement, in this case, we actually say delete from Z employees. So delete from table name where the field equals and the contents of the field. Do a check. And we activate. And then let's do a test. Now we already have, let's have a look, 6, so we'll delete that. Because our program will recreate it. Scoot that across to the side, set our breakpoint, and then let's test our code. Let's bring the table in, refresh, there's our 6, we have the 10 and the 1. So we will go step by step again. So see here, our Z employees, oops, need to get the field name correct. And of course it's Z employees, so I'm well out. WA employees, Z employees. Is it employee? Oh, let's have a look. I'll scoot up a little bit, make sure I get the field correct. WA employees, employee. There we go. So, if we step through, this one statement should have deleted both records. We know it was successful because SY sub RC is 0. Come back, have a look at our table, do a refresh. Hopefully 1 and 10 will disappear, and they do. And then I will just zoom to the end of the program. And there we have our output. Let's take this breakpoint off. So that's the second form of the delete statement, where you can use logic. Now the last thing I just want to mention is that if you use the delete statement in the following form, here we go, delete from Z employees, this form of it is what I said earlier you need to be careful about, because this will delete all the records from our table. That wraps up the delete statement.